So we'll understand a little bit about functions in Python. Those of you who are familiar with programming languages like C, C++, or Java would already be aware of functions. Python functions have a slightly different syntax, but for all logical purposes, they behave very much like a C, C++, or Java functions. Of course, there are some subtle differences. And functions actually help you break down your program into smaller and modular chunks, which you can reuse if you choose to. So functions is a very good programming habit. If there is any snippet of code, if there is any snippet of code that you have to reuse multiple times in your program, it's better to put it into a function and call the function. That makes your code more reusable and more manageable, right? So now let's understand the syntax of functions in Python, right? So all functions are defined with a keyword def, right? Then you have the function name. Whatever parameters you want to pass are in parentheses, and there is this colon at the end, right? When you have this colon, it means everything from here now is the definition of the function. Now look at because we don't have curly braces like in C, C++, or Java, everything is done with indentation. So as soon as you have indentation, so after your colon, everything that is indented is part of your function body, or is part of your function, the code within your function, right? So return statements are optional. Just like your return statement in C, C++, Java, we have return statements in Python also. They are optional. So instead of going through theory, let's go through some simple examples to understand. So imagine if I have a function like this. Okay, so let's take a simple example. I'm using the def keyword here. My name of the function is print_name. I'm passing a variable called name and the semicolon here. If you notice, all these lines are indented. So this indentation shows that this whole thing is the body of my function, right? The first three lines, the first three lines that you notice here, which are enclosed in triple quotes, is called the doc string. This is called the doc string. Docstring basically literally tells us about what the function does. So writing docstrings is a good programming practice. It's a very good programming practice that I strongly recommend each of you to follow. Now, when we have this thing when we have docstrings, it's very easy for us to understand what the function does. I don't have to go through and read the whole code of the function. So this function literally what it does is written as a string. Anything in triple quotes is a string, right? So it says this function prints the name, right? And what I'm doing here, I'm just printing hello and concatenating with name, and I'm just printing it, right? Now this is how I define a function. Remember, this function has no return statement, right? Now since it doesn't have a return statement, now when I call print_name and give a name, Satish, who's one of our engineers here, when I just say this, what it'll do is it'll just go here. So as soon as I call this function, it literally goes here and starts executing line by line. So one of the lines that it executes is print hello, hello plus string of name, right? So it will print hello Satish, and at the end of it, it will come out and come here, right? So docstring, as I was telling you earlier, docstrings are very, very useful. They help you understand what the function does internally. It's a good programming practice. For any given function, if you want to print the docstring, it's very, very simple. You just give the function name. Dot two underscores. These are two underscores here, right? Doc, again, two underscores. This is a variable. For every function, there is this variable called __doc __. What this gives us is it prints us the docstring for any given function. Now, whether the function that we have is defined by us, sorry, I apologize for that. So whether the function we have is written by us or by someone else, for any given function, I can easily get the docstring by just saying function name dot __doc, right? So for our since print name was defined by us, when I just say this, what I get here is this function prints the name, which is exactly the docstring that we gave when we defined the function, right? This is the docstring that I gave when I defined the function, isn't it? So it's a very, very simple way for other users of our functions to understand what's happening. So return statements basically returns as a value. So let me explain you I think it's better to follow through an example. Suppose imagine if I want to write a function called getSum, which takes a list, right? And it returns me the sum of all the elements in the list. For example, if I have a function like this, so suppose I'm calling this getSum function with a list, and my list contains 4 elements, 1, 2, 3, and 4. Right? What I want is my getSum function takes this list, sums up all the elements in this, and provides that value puts that value into S. right? Now when I do print s, I got 10, which is nothing but the sum of all these numbers, right? Now the question here is, how do we now return values back from functions? That's very simple. Here is my docstring. This docstring says this function returns the sum of all the elements in a list. I'm initializing a variable called underscore sum. By the way, variables can have underscore as their first character. It's perfectly legit. It's perfectly okay in Python, right? I'm declaring a variable called sum and initializing it to 0. And I'm writing a simple for loop here where I'm taking each element in the list and I'm adding that element to sum. And at the end, this line is important. At the end, what I'm doing here is I'm returning sum. So when I return sum, whenever I call this function, when I call this function, it returns me the sum of all the elements here, and that I can allocate it to a new variable called s, right? So that's what return statements are. One thing you'll notice is in our previous function that we defined, in this function there is no return statement. Okay, so one thing we have to notice is return statements are optional. Return statements are optional. So return statements are optional. When you do not return anything explicitly, Python returns a none object. Okay, Python automatically always returns none whenever you have not explicitly given whenever you have not explicitly returned anything explicitly, right? It returns none by default, right? Now, okay, so this is the docstring that we just saw. Now let's see how functions in general work. Let's assume this is my original code. Let's look at it here, right? This is my function body. Okay, suppose I'm executing a line. At this line, when I call the function name, what happens is immediately I go into the function. I run all the lines of code in the function. At the end of running the last line in the body of the function, I come back to the next line wherever of the code that I have left from. This is how logically it works, right? This is important. So I first run this line. This is my third line. When I go here, I run my fourth line, I run my fifth line. After my fifth line, now I come here. Okay, so logically, the execution path of your code is like this: 1, 2, 3. It goes into the function. 4 and 5, and then it comes out 6 here. Right. So this is how functions execute. This is the flow of execution when you have a function. Now let's go and understand a couple of very important concepts called scope and lifetime of a variable. Now, scope of a variable is basically the portion of the code or the program where the variable is recognized, right? And lifetime is basically the period throughout which the variable exists in memory. They need not be same. Scope and lifetime could differ in some cases. But let's take a simple example. I think that'll be beneficial, right? So let's take this code. Here, what am I doing here? I'm creating a variable called global variable, which is outside all of my functions, right? Here I have a function body. In this function body, I'm creating a variable called local variable. Any variable that is defined and used within a function, as soon as you come out of the function, the variable disappears. That's what I've written here. That's what we have here. Variables are destroyed once we return from the function. Variables that are declared and that are defined within a function will be removed from memory as soon as we return from here. Okay, so let's see. So I have a variable called local variable here. I have a variable called global variable. Now my code starts running here. Right, my global variable has the string which is this is global variable. Then I have a function definition here. Nothing happens. This doesn't run. Right, now this runs. When I say test lifetime, now what happens? It goes here. It starts running this. Okay, here I'm printing the local variable and the global variable. Since the global variable is declared outside this function, I can access this global variable internally. Right, which means I can access the scope of this global variable is the whole area, including inside the functions. So when I print local var and print global var, if you look at my output, I get, okay, this is local variable, this is global variable, right? Now, after printing my local and global variable, I come back here because this is where I called the function, right? So at the end of the function, I come back here. Now here I try to print my global variable, it prints successfully. Now here is the catch. If I try to print local variable now, it literally raises an error, right? So now I'm trying to print my local variable. What happens is this line, because remember, if you notice, the local variable is declared inside this function, right? As soon as I come out of the function, that local variable cannot be accessed anymore, right? But I tried to access it. Now let's see what type of error it would give. Here I'm saying print local var. As soon as it says that, it gives me something called a name error, and it says local var is not defined to start with. I don't know what local var is, and it has raised this error for us. So with this program, we can understand the difference between a variable that is defined within a function and outside the function. This, of course, the idea of scope and lifetime of variables is much more intricate. It's very programming specific, but this example gives you a high level overview of what scope and lifetime of variables, of local variables and global variables are. Okay, now let's write a very, very simple program here. I just wanted to take a small, simple program like your undergraduate first year days, where we're trying to find the highest common factor of two numbers. What is the highest common factor? Let's say if you take two numbers, let's say 12 and 14, right? 2 is the largest number that can divide both 12 and 14. There is like any other number, 3, 4, 5, 6, any number greater than 2 cannot divide 12 and 14. So HCF basically is, HCF of any given set of numbers is basically the number, the largest number or the highest number that can divide all of these numbers exactly, right? So how do you write that function? So here is how I'm writing my function. I'm calling this function compute HCF and I'm giving two numbers. Here is my doc string, right? Here is my doc string, and this is the logic. The logic here is very straightforward. What I'm saying here is I am basically picking the smaller of these two numbers. If I'm given two numbers, I pick the smaller of the numbers and I check the numbers from 1 to the smaller of the numbers, right? And I try to see which is the largest number which can divide both your A and B. It's a very, very simple code here. Now this is how I compute my HCF. Now I'm outside this function. I'm defining two variables here, num1 and num2, and I can just compute HCF of num1 and num2, and that will be 2 because no number greater than 2 can divide both of them. So very, very simple code. This is a simple for loop that we all understand logically. So what are we doing here? We are finding the smaller number and we are saying in the range of 1 to the smaller number, keep checking. So for example, if when I input 98 and 78, what is the smaller number? Smaller number is 78. So between 1 to 78, I'll keep checking like 2, 3, 4, so on, so forth, 77. I'll keep checking which of these numbers, which of these numbers can divide both A and B, can divide both 98 and 78. And whichever is the largest number that can divide, I'll keep it in this variable called HCF. And the end of it, I'm returning this variable called HCF. Very, very simple program. It's very, very easy to understand. Those of you who are new to programming or who do not know programming a lot, please go through this in careful detail so that you understand how to write a function, how to build the construct, how to construct the basic logic to solve a problem like this.